Here's the part that should stop you in your tracks. If the moon's orbit tilted by just a few more degrees, tonight wouldn't be a near total eclipse. It would be a full blood moon, the kind that makes international news and ends up in textbooks. Instead, we're getting 96%. So close the difference is almost invisible to the naked eye, and that missing 3.7% is the entire reason tonight's eclipse has a name most people have never heard of. By the end of this video, you'll know exactly why this eclipse exists, why it's happening precisely 2 weeks after a solar eclipse on the other side of the planet, why the moon turns red even in total shadow, and why, if you miss tonight, you're waiting until the final hours of 2028 for anything like it again. So if your plan was to glance up for 10 seconds and go back inside, stick around first. Once you know what's actually happening up there, you won't want to look away. Let's start with something that sounds simple but genuinely isn't. What is a lunar eclipse? Most people could give you the textbook answer. The Earth gets between the sun and the moon. The Earth's shadow falls on the moon. Done. But here's the question. Almost nobody asks. If that's all it takes, why doesn't this happen every single month? Think about it. Every 29.5 days, the moon completes a full orbit around Earth and lines up in a full moon phase, meaning the sun, Earth, and moon are roughly in a straight line with Earth in the middle. By that logic, we should get a lunar eclipse every single month without fail. We don't. In an average year, there might be 0, 1, or 2 total lunar eclipses, sometimes none at all. So what's stopping the other 10 or 11 full moons from being eclipses too? The answer is a 5-degree tilt. That tilt sits at about 5.1 degrees, and it isn't flat against the same plane as Earth's orbit around the sun. It sounds tiny. It sounds like it shouldn't matter. But at a distance of 238,000 miles, a 5-degree tilt is more than enough to send the moon's shadow, or in this case, Earth's shadow, missing its target completely most months of the year. Picture 2 circles that almost never touch. One is the plane Earth travels around the sun. The other is the plane the moon travels around Earth. They cross each other at exactly 2 points, called nodes. And for an eclipse to happen, solar or lunar, the moon has to be sitting almost precisely at one of those 2 crossing points at the exact moment it's in a new or full phase. Most months, the full moon sails right past Earth's shadow. It misses entirely, above it, below it, never touching. That's why you've seen dozens of full moons in your life and only a handful of actual eclipses. Tonight is different. Tonight, the moon is close enough to one of those 2 crossing points, close enough to a lunar node, that it's about to plunge directly into Earth's shadow. But here's where it gets interesting. Close enough is not the same as perfectly aligned. And that distinction, the gap between close and perfect, is the entire reason tonight is going to look the way it does. Here's what that gap actually costs the moon tonight, and it comes down to a number you're about to see for yourself. Earth's shadow, when you actually study it, isn't a single uniform blob of darkness. It has 2 distinct layers, and understanding them is the key to understanding tonight. The outer layer is called the penumbra. This is the lighter, fuzzier edge of Earth's shadow, the region where Earth only partially blocks the sun's light. If the moon passes through only the penumbra, the effect is so subtle that most casual observers wouldn't even notice anything happened. The moon just looks slightly dimmer than usual. No dramatic color change, no headlines. Deeper still is the umbra, the dark heart of Earth's shadow, the region where Earth completely blocks direct sunlight. This is where the real show happens. When the moon enters the umbra, that's when you start to see a visible bite taken out of the lunar disk, growing larger and darker as the moon moves deeper in. Tonight, the moon is going to plunge almost entirely into that umbra, 96.3% of it to be exact. Just before 10:34 p.m. Eastern Time, the moon will begin crossing into that dark inner shadow. Over the next roughly 2.5 hours, that shadow will creep further and further across the lunar surface, like ink slowly spreading across paper, until it reaches its absolute maximum at 12:12 to 12:13 a.m. Eastern, 9:12 to 9:13 p.m. for anyone watching from the West Coast. At that peak moment, everything except a thin, bright sliver along one edge of the moon will be sitting inside Earth's darkest shadow. Stay with this next part, because it's the single detail that explains everything you'll see tonight. Now here's the question that should be bothering you. Why isn't that thin sliver also covered? Why does the shadow stop at 96% and not just keep going? The thin sliver traces back to the same node alignment we just covered. Tonight, the moon's path is taking it very close to the center of Earth's umbral shadow, but not perfectly through the center. It's slightly offset. Picture a target with Earth's umbra as a circle in space and the moon as a smaller circle passing through it. If the moon's path takes it directly through the bullseye, you get totality. The entire moon disappears into shadow, and depending on how close to center it passes, that totality can last anywhere from a few minutes to well over an hour. But tonight, the moon's path clips the edge of that shadow circle instead of cutting straight through the middle. It's deep enough that almost the entire lunar disk gets swallowed. But that small offset, driven by exactly how close the moon is to its orbital node tonight and no closer, leaves that thin final sliver of the moon outside the darkest part of the shadow, still catching direct sunlight. That sliver is the entire difference between tonight's event and what astronomers call a total lunar eclipse. And it comes down to geometry measured in fractions of a degree, playing out across 250,000 miles. This is, by the way, the deepest partial lunar eclipse anywhere on Earth since September 2024. Astronomers aren't calling this an ordinary partial eclipse, they're calling it a deep partial, or in more colorful terms, an almost blood moon. Because at 96%, the visual difference between this and full totality is going to be genuinely hard for most viewers to spot with the naked eye. Here's a question that stops most people cold when you actually ask it out loud. If the moon is sitting inside Earth's shadow, completely blocked from direct sunlight, why does it turn red instead of just going black? Think about what a shadow actually is. It's the absence of light. When you stand in a shadow on a sunny day, you don't turn orange, you just get darker. So logically, when the moon slides into the darkest part of Earth's shadow, shouldn't it simply vanish? Shouldn't it go completely black, invisible against the night sky? This is one of the most genuinely counterintuitive things about eclipses, and it took astronomers centuries of observation to fully explain it. The answer is that Earth's shadow isn't actually empty. It's not a perfect void of nothingness, because Earth has an atmosphere, a roughly 60-mile thick layer of gas wrapped around the planet. Sunlight doesn't just get blocked outright, some of it gets bent. Picture sunlight grazing past the curved edge of the Earth as it travels toward the moon. It has to pass through our atmosphere at a low, glancing angle. That thick slice of atmosphere acts almost like a lens, bending, or refracting, some of that sunlight inward, curving it around the edge of the planet and funneling it toward the moon, even though the moon should technically be completely blocked from the sun's direct view. But it's not just any light that makes it through. As sunlight travels through our atmosphere, it collides with countless gas molecules along the way, and this triggers something called Rayleigh scattering, the exact same phenomenon that makes our sky blue during the day and our sunsets orange and red in the evening. Blue and violet light waves are short and get scattered away easily, bouncing off in every direction almost immediately. Red and orange light waves are longer. They push through the atmosphere far more efficiently, surviving the journey with much less scattering. So by the time sunlight has traveled all the way around the curve of the Earth and reached the moon, almost all the blue light has been filtered out along the way. What's left, what actually makes it through to illuminate the lunar surface, is mostly red and orange light. What that light is actually made of is about to change how you see every red moon you ever watch again. In other words, every sunrise and every sunset happening anywhere on Earth right now is being projected all at once onto the surface of the moon. That reddish glow you'll see tonight isn't the moon's natural color. It's the combined light of every sunrise and sunset on the planet, bent around the edge of the Earth and cast onto our nearest neighbor in space. That's not folklore. That's not poetic exaggeration for a YouTube script. That is the literal, measurable physics of what's happening in the sky tonight. And here's a detail that most articles won't tell you. The exact shade of red isn't fixed. It changes from eclipse to eclipse, and nobody can predict it with total certainty in advance. If there's been a major volcanic eruption somewhere on Earth recently, extra dust and ash lingering in the upper atmosphere can scatter even more light, sometimes producing eclipses so dark they're almost brown or gray instead of red. Clear atmospheric conditions, on the other hand, tend to produce brighter, more vivid orange and copper tones. So tonight, when you look up and see that faint reddish tint creeping across the shadowed part of the moon, you're not just seeing an eclipse. You're seeing a live readout of the current state of Earth's entire atmosphere, reflected back at us from 250,000 miles away. Now, here's something that should genuinely unsettle you a little in the best way. Exactly 2 weeks ago, a total solar eclipse swept across Spain, a sliver of Portugal, Iceland, Greenland, and northern Russia, plunging parts of southern Europe into daytime darkness as the moon passed directly in front of the sun. And tonight, precisely 14 days later, we're getting a near-total lunar eclipse. Is that a coincidence? A calendar quirk? Something astrologers have quietly known for centuries and everyone else just forgot? No, it's one of the most reliable patterns in the entire solar system. And once you understand why it happens, you'll never look at eclipse pairs the same way again. Remember those two crossing points we talked about earlier? The lunar nodes, where the moon's tilted orbit intersects with Earth's orbital plane. For an eclipse to happen at all, solar or lunar, the moon needs to be close to one of those two nodes at the same time it's in a new moon phase, for a solar eclipse, or full moon phase, for a lunar eclipse. Here's the key detail. The moon only stays close enough to a node to trigger an eclipse for a window of roughly 34 to 37 days at a time. A stretch astronomers call an eclipse season. And because a full moon and a new moon happen exactly 2 weeks apart from each other in the lunar cycle, if a new moon happens to fall inside that eclipse window and triggers a solar eclipse, there's an extremely good chance the very next full moon, 14 days later, will still be inside that same window, close enough to the node to trigger a lunar eclipse too. That's exactly what happened this month. The new moon on August 12th lined up close enough to a node to produce that total solar eclipse over Spain, Iceland, and Russia. 14 days later, the full moon, tonight's sturgeon moon, is still close enough to that same node to plunge into Earth's shadow. This pattern is old, older than you'd guess, and someone was already tracking it 2,500 years ago. This isn't a rare fluke. It's a predictable rhythm baked into the mechanics of the Earth-Moon system, and it's been happening for as long as the moon has orbited the Earth, which is to say, for roughly 4.5 billion years. Ancient civilizations noticed this pattern long before they understood why it happened. Babylonian astronomers, more than 2,500 years ago, tracked a repeating cycle of eclipses now known as the Saros cycle, a period of roughly 18 years, 11 days, and 8 hours after which the Sun, Earth, and Moon returned to almost exactly the same relative positions, producing an almost identical eclipse. They didn't have telescopes. They didn't have orbital mechanics. They had centuries of careful record-keeping, clay tablets, and patience, and they used it to predict eclipses with startling accuracy, treating the sky less like a mystery and more like a machine with a schedule you could actually learn to read. Without even realizing it, you're witnessing tonight the same mechanical rhythm those ancient astronomers spent their entire careers decoding. Set an alarm tonight instead of just catching this by accident. This next part is why. This deep partial eclipse, this 96.3% near total event, is officially the deepest lunar eclipse anywhere in the world since September 2024. And it's going to remain the best lunar eclipse available to sky watchers until December 31st, 2028, stretching into January 1st, 2029, an event astronomers have already nicknamed the New Year's blood moon eclipse. That's not an exaggeration for dramatic effect. That's the actual astronomical calendar. Why such a long gap? Because of everything we've just walked through. Total and near total lunar eclipses depend on a very specific, narrow alignment. The moon has to be almost perfectly positioned at one of its 2 orbital nodes during a full moon, with Earth's shadow deep and dark enough to produce a dramatic visual effect. That precise combination simply doesn't happen very often. Even the eclipses coming next won't come close, and knowing why will save you from setting an alarm for nothing. In fact, the years immediately following tonight are going to be relatively quiet for lunar eclipse fans. 2027 is expected to bring 3 lunar eclipses, but all 3 are what's called penumbral eclipses, meaning the moon only grazes the lighter outer edge of Earth's shadow, the penumbra we talked about earlier, without ever reaching the dramatic darkening and reddening of the umbra. To the casual observer, a penumbral eclipse is almost disappointingly subtle. The moon looks slightly dimmer than usual, and that's about it. No visible bite taken out of the lunar disk, no reddish glow. Easy to miss entirely if you're not specifically looking for it. So between tonight and the very last moments of 2028, there is no lunar eclipse coming that will look anything like what's happening in the sky right now. This is also worth putting in context. Tonight's eclipse follows on the heels of a total lunar eclipse back in March of this year, and that March eclipse was itself the 3rd total lunar eclipse in a row, following ones in March and September of 2025, a stretch of unusually active eclipse activity. Tonight effectively closes out that active period. What comes after is a long, quiet stretch, at least as far as lunar eclipses are concerned. If you've ever told yourself, I'll catch the next one, tonight is not the night to say that. The next one that actually looks like this is truly more than 2 years away. So now that you understand exactly what's happening and why it's rare, let's talk about how to actually see it. Because unlike a solar eclipse, this one comes with almost no rules. First, and most importantly, this is completely safe to watch with your bare eyes. No special glasses, no solar filters, no protective equipment of any kind. A lunar eclipse is nothing more than Earth's own shadow falling across the moon, and shadows can't hurt your eyes no matter how directly you stare at them. Binoculars or a telescope will absolutely enhance the view, bringing out surface detail, craters, and the gradient of color as the shadow deepens. But they are entirely optional. Your unaided eyes are enough. For viewers across the continental United States, here's the timeline you actually need. The moon rises in the southeastern sky around sunset, appearing full and bright before anything unusual happens. The partial umbral phase, the moment Earth's shadow visibly starts biting into the lunar disk, begins around 10:34 p.m. Eastern Time, 9:34 Central, 8:34 Mountain, and 7:34 Pacific. From there, the shadow deepens gradually over roughly 2.5 hours, reaching its maximum darkness, that 96.3% coverage at 12:12 to 12:13 a.m. Eastern, which works out to 11:12 p.m. Central, 10:12 p.m. Mountain, and 9:12 to 9:13 p.m. Pacific. After maximum eclipse, the process reverses, with the shadow slowly retreating off the lunar surface until the moon returns to its normal full brightness by roughly 1:59 to 2 odd a.m. Eastern Time. All told, this entire event, start to finish, spans an unusually long 5 hours and 38 minutes, one of the longest lunar eclipses in recent memory, giving you a wide window to catch it, even if you can't stay up for the exact peak moment. There's still one thing that could ruin all of this for you tonight, and it has nothing to do with timing. Location-wise, you genuinely don't need anything special. Unlike stargazing for faint objects like meteor showers or the Milky Way, you don't need to escape city lights or drive out to some remote dark sky location. A lunar eclipse is bright enough and large enough that it's visible from almost anywhere with a clear view of the sky. A backyard, a rooftop, a parking lot. The only real requirement is an unobstructed view toward the southeastern to southern sky, away from tall buildings, hills, or trees that might block your line of sight, along with, ideally, clear weather. This eclipse won't just be visible from the United States either. Skywatchers across Canada, Mexico, Central America, Brazil, and much of South America, the United Kingdom, and large parts of Europe and Africa will all get a view of tonight's event, making this one of the most widely visible eclipses of the year. And if clouds do roll in and ruin your view, which, depending on your local forecast, is a real possibility tonight, you're not completely out of luck. Observatories, including Griffith Observatory in Los Angeles, are opening their grounds for public viewing and streaming the event live online, giving you a backup option even if the sky above your own house doesn't cooperate. So here's where we land. Tonight, at almost exactly the same moment across the entire country, Earth is going to slide between the sun and the moon and cast a shadow across 96.3% of the lunar surface. A shadow shaped by 5-degree orbital tilts, by 2 crossing points in space called nodes, and by a window of alignment that only opens for about a month at a time, a handful of times each year. That shadow won't be empty. It'll be filled with the bent, filtered light of every sunrise and every sunset happening on Earth at this exact moment, all of it curving around the edge of our planet and landing on the moon as a deep, coppery red. This eclipse exists because of a solar eclipse that happened 14 days ago on the other side of the planet, a pairing that's been repeating, predictably, for billions of years, and one that ancient astronomers were tracking with clay tablets thousands of years before anyone understood why it worked. And once it's over tonight, that specific combination, depth, visibility, timing, won't line up again until the very last hours of 2028. You don't need a telescope. You don't need a dark sky location. You don't need to travel anywhere. You just need to step outside sometime between roughly 10:30 tonight and 2 a.m., look toward the southeastern sky, and watch something that has been happening in this exact rhythm since long before human beings existed to notice it, and won't happen quite like this again for more than 2 years. Set a reminder. Step outside, look up. Because the sky doesn't wait for anyone to be ready.